Any idea how this works?
N, let's start positive. Let's reckon n minus 2 equals m. List all the possible numbers they could be. So it says that n and m both positive integers less than 6, so they can't be any bigger than 6. So list all the possible numbers they could be. So for starters, we could do 4. Well, n could be 4 minus 2 is m, which is 2.
Yeah, so they both have to be less than 6. So it could be n is 4, m is 2. That works.
It can also be 5 minus 2, which is 3. So n could be 5 and m could be 3.
Yeah. So 4. Yeah. Okay. Go on. Anything else?
N could be 2. So 2 minus 2 is 0. So m could be 0.
0 isn't positive.
Wait, so 3 minus 2 is 1.
Yeah.
Let's see what else. There can also be. We've done that. Just trying to think of some more. Actually, I think that might be it.
That's correct. There's only those 3 possibilities. Well done. So I'll leave that one. That's 1. That one. That's 2. 3. That's 2 of those. Less than 7. I think you'll be fine. That didn't give you any trouble. Let's try this one.
Okay. In this equation, a and b stand for positive integers less than 7. List all the possible numbers they could be. So for starters, we could do a could be 1, so it would be 1 plus 4, and b could be 5. And we can also do 2 plus 4, which is 6.
Mm-hmm.
We can't do 3 plus 4 because that equals 7, and they have to be less than 7.
Mm-hmm.
0 isn't a positive number, so I think that's it.
Correct. Let's try this one.
Okay. Kerry is trying to work out the possible answers to this formula. n plus 7 minus 2 equals n. She knows that m and n are positive integers less than 10. She thinks m could be 4 and n could be 8. Is Kerry correct? Explain how you know yes and no. So the formula itself is m plus 7 minus 2 equals n, and m and n have to be less than 10, and so Kerry thinks that m could be 4 and n could be 8. So if we were to do that, then it would be 4 plus 7 minus 2.
Mm-hmm.
And so 4 plus 7 is 11. And 11 minus 2 is 9. So is Kerry correct? No.
Not correct. Why not?
Yep, not correct.
Yeah, I think that's enough to say. So when m is 4, what is n?
When m is 4, so when m equals 4, n equals 8. Wait.
That's what they thought.
Okay, I'm getting confused again. So n would need to be 9.
Yes, that's why. They're not correct because when m equals 4, n equals 9.
Yes.
No. Okay. So 2 unknowns, x a half or a tick.
I think maybe a tick.
Okay.
Combination problems ask you to work through all the possibilities in a situation. A t-shirt comes in 3 colours, red, green and blue, and in 3 sizes, large, medium and small. This picture shows all the different possible t-shirts. So, combination. So the t-shirt comes in 3 colours, red, green and blue, and in 3 sizes, large, medium and small. And then it says this picture shows all the different possible t-shirts. So need to well because this is a combination problem. I guess I think we would need to like show all the combinations possible.
Correct.
So the first combination could be red, large, wait, does it have to be all 3 colours together? Or can they be separate?
Hang on. So you've got 3 colours and 3 sizes. So what are all possibilities?
Okay, so we can do red in large, green in large, blue in large, and maybe I think you can. There's red medium, green medium, and blue medium, and there's also red small, green small, and blue small.
That's it. 9 possibilities in total. And you can use a table. Okay, how about this bottom one down there?
So the example, okay. Gareth makes a sandwich from one type of bread with 1 filling. You can choose white or brown bread, and the fillings are jam, cheese, egg, and tuna. Draw a table of all of the different combinations you could choose. Well, so it says that you can choose between white or brown bread, and the fillings are jam, cheese, egg, and tuna. So, first combination you could choose is white bread with jam filling.
Yeah.
And you can also use white bread with cheese. Also white bread with egg. And white bread with tuna. And you can also She's brown bread with jam. Brown bread with cheese. Brown bread with egg. And brown bread with tuna.
Well done. And that's what the table might look like. Okay. Let's see. I think you'd be fine for that one.
Okay.
Boots, sandals. Wow. Okay, so let me just check something. Yeah, let's do this one. It's a big one.
Okay. Frankie likes 4 types of footwear: boots, sandals, trainers, and wellies. He buys each type in 3 different colours: black, brown, and green. Complete the table of combinations. So we already have some combinations put together for us, so we don't need to worry about them. The first one, however, is black blank, but I suppose that could be black boots. Or
yeah, okay, so let's make that boots then.
next, we can also use black. Let's see, black sandals.
Mm-hmm.
And also black wellies. And the second row down is we can use brown boots.
Yeah.
We don't need to worry about brown sandals, as that's already done. Brown trainers.
Mm-hmm.
And brown wellies. And now onto the last row. We already have green boots, so we don't need to worry about that. There is green sandals. Green trainers. And green wellies.
That's it. Well done. So that time there was 12 things. Tea,
Okay.
coffee, hot chocolate, cream. That one's okay. There's 9. We did one like that.
Okay.
Huh. Okay. Let's try this one.
Okay. The U6 girls are playing the U6 boys in a netball match. The final score is 2-2, or 2-all. What could the half-time score have been? List all the possible scores. So the half-time score. So first we could do 1-all, I guess.
Okay.
We can also do 1-2. We can also do 2-1. And I believe that's it, apart from 2-all.
There's another possibility. Many more.
Many more. Oh.
What if it was a football match?
I thought we'd know. Oh. Well, there's also 3. Well, actually, no, there's also 2-3. Well,
the final score was 2-2, so the half-time score couldn't have been more than that.
We've done 1-2. We've done 2-1. 1 or 1-2. They can also be 0, like 0-all.
Well done.
Yeah, I have been that. There's also 0-1.
Mm-hmm.
There's also there's also 0-2. And there's also 1-0. 2-0. And and there's also 2-2 as well, which is the final score.
That's a good point, actually. If it could have been 2-2 at half time.
Yeah. So, I'm just trying to think. I think that may be all the possible combinations.
Yeah, I think that's it.
Okay, so
That's 8, and we have 1, 2, 6, 3, 9. Is it 1, 2, 3, 4, 5, 6, 7, 8, 9? That's it.
okay.
Yeah. And so what might help is if you do this using some kind of a system. So if you started with the smallest one, which is 0, 0,
Yeah.
and then you could do 0, 1, 1, 0, 1, 1, 2, 0, 2, 1, and 2 all. Did I miss any from there?
You did. Well, I was able to. Well, we were able to think of 9 on the other side. So, you missed. Oh wait, I can see a couple that you missed.
Yeah. So, well, it's just a tricky one. It's not easy to follow a system for this one, I suppose.
No.
Okay. And how about this crazy one?
Okay. In a field, there are some farmers and some sheep. The total number of legs is 100. What combination of farmers and sheep could be in the field? List 3 possible combinations. Okay, so the first one is kind of a bit obvious. There could be 50 farmers at, wait, no. Actually, never mind. There could be 10 sheep, so that would be 40 legs in total, because sheep have 4 legs. And there could be 60 farmers.
So 10. Yeah. Sheep. And 60 farmers.
It can also, actually, no, it can't be the other way around, because sheep have 4 legs. There can also be, let's see, I think that also, no, it can also be 20 sheep and 20 farmers.
Yeah. Good one.
And there can also be 30 sheep and 10 farmers.
They have 4 legs each.
Wait, so 30 sheep. 4 times 30 is above 100. I don't know. There can also be 5 sheep, so that would be 20 legs. And there could be 95 farmers.
How many legs do 5 sheep have in total?
20. Oh yeah, 20. So 20. Wait, no, not 20. Yeah, wait. Yeah, 20 legs for sheep.
Mm-hmm.
And then 80 farmers.
Yes. Any questions there?
Nope, I don't have any.
Okay, so combination problems, X, a half, or a tick.
I think maybe a tick, perhaps.
Okay. And algebra problems. So this is when they... Oops. This is towards the end of algebra.
Okay.
So it's lots of different stuff put together. Okay. Let's try this one.
Okay. So you can use algebra to help you solve problems about unknown numbers, solving problems with algebra problems. When trying to solve problems about unknown numbers, it can help to write number sentences and think about the possible numbers that would make them true. Look at the problem below. A and B each stand for a whole number. A plus B equals 8. B is 3 times as large as A. What are the values of A and B? So, looking at this table, we know for a fact that A and B are both whole numbers, so they're not decimals or anything. They when added together, they equal 8 together, and we also know that B is 3 times as large as A. So I'm thinking maybe, because does it say that B is 3 times as large as A? I'm thinking maybe B could be B is 6 maybe.
And so A would be?
2.
So, and does that work? A plus B equals 8, and B is 3 times as large as A.
Yes, because
And
6.
so,
Yeah, 2 times 3 is 6.
so A equals 2 and B equals 6.
Yes.
So there was lots of possibilities. A is 2, B is 6. Okay, how about this one?
Okay. A and B each stand for a whole number. A plus B equals 25. A is 4 times as large as B. What are the values of A and B? So again, A and B are both. We know for a fact that straight away A and B can't be decimals, because they're both whole numbers. And when added together, they equal 25. And A is 4 times as large as B. And then what are the values of A and B? So I'm thinking maybe that just trying to think. Well, I'm thinking maybe that A could be 20 and B.
A equals 20, B equals 5. That's it. I think you'll be fine there. You might be fine. I think you'll be fine. Okay. Algebra problems.
I think maybe nailed it again. So reading scales. There are lots of different types of measuring equipment. You need to be able to read the scales to take a measurement. Find the size of each interval. To read scales, you first find out what each interval is worth. So in the bottom picture, it shows like a container has been filled up, and by the looks of it, it's so that's 150. By the looks of it, it's 100 and by the I forgot what I was doing.
So what would be the line here in the middle, this kind of big one?
Well, that would be halfway between 150. Well, that's halfway between 150 and 200.
Mm-hmm.
I'm thinking it's 175 milliliters.
Okay, so that's 175, and so the one above it?
The one above it must be 180 milliliters.
So we think it's 180. Can you count how many lines there are between 150 and 200?
1, 2, 3, 4, 5, 6. Well, without including 200, there's 9 lines.
And so in total it'd be 10 if you include 200. So 10 lines.
Yeah, 10 lines.
And what's the difference from 150 to 200?
50.
So 10 lines are 50 milliliters, and so one line?
And one line must be 10 milliliters.
What do you divide 10 by to get 1?
You divide it by 10.
And so 50 divided by 10?
5. Oh yeah.
Yes. And so we're correct. One line is 5 milliliters. That's 175, so one more is 180.
Okay.
And that's kind of the proper way of doing these. So that's 180. Okay, how about this one?
Okay, so what mass is the arrow pointed to? Now, for this, it's a kilogram scale. So, and looking at it, it's almost pointing at 4 kilograms, but it's not quite there. But looking at it, we can tell that it's over halfway between 4 and 3. So and including well, we know that there are 10 lines between 3 and 4.
Mm-hmm.
And so and
so 10 lines add up to what?
10 lines add up to 1 kilogram.
Yeah.
And so the arrow is pointing at the 8th line between 4 and 3.
Mm-hmm.
So the mass that the arrow is pointing to must be 3.8 kilograms.
Well done. 3.8 kilos. Any questions about that one?
Nope, I don't have any.
Okay, let's try these.
Okay, so read each scale, and there's A, B, C, and D. Now for A, it's kind of like a number line thing, but so for A, it kind of looks like a number line thing, but the line is basically between 0 and 2 kilograms.
Mm-hmm.
And we know that there are And we know that there are 10 lines between 0 and 2 kilograms.
Mm-hmm.
And the red arrow is pointing at the 4th line between 0 and 2 kilograms.
Mm-hmm.
So what the arrow is pointing to must be 0.4 kilograms.
Well, 10 lines add up to what?
Well, they add up to 1 kilogram.
They don't add up to 1 kilogram.
No, they add up to 2 kilograms in this case.
Mm-hmm.
And the halfway point must be 1 kilogram.
Mm-hmm.
But that's in the very middle. So it must be 0.9 kilograms.
So 10 lines make 2 kilos. What would one line make?
One line, well, 10 divided by 10 is 1. And so 2 divided by 2 divided by 10 is 0.2.
Yes, 0.2 kilos. And so 1 back from 1 kilo isn't 0.9. What is it?
It's 0. It's 0.99 kilos.
It is 1 kilo minus 0.2.
So 0.8.
Yeah. Yes. So they're not going up in ones, they're going up in 0.2s. And next one.
For B, it's basically by the look of it, it's basically a speedometer. The arrow is pointing between 60 and 70. So, and in this case, there are 5 lines between 60 and 70 miles per hour.
Mm-hmm.
And so, and we know for a fact that halfway between 60 and 70 is 65.
Mm-hmm.
And yeah, what was I going to say? So yeah, half between is 60 and 65. So because the arrow is pointing in the middle of 60 and 70,
Mm-hmm.
that means the arrow.
Say again, sorry?
Actually, the arrow must be pointing at 65 miles per hour.
It's not halfway. So what do 5 lines add up to?
Well, they add up to 1 mile per. Well, no, in this case they add up to 70.
And it starts from 60?
5 lines add up to 65.
No. From 60 to 70? So that's 5 lines add up to?
No. 5 lines add up to 70.
But it starts from 60.
No, 5 lines add up to 69.
How many is it from 60 to 70?
10.
So those 5 lines add up to 10.
Okay.
So what must 1 line be worth?
Well, 1 line must be worth 2 miles per. No.
Yeah.
Yeah, 2 miles per hour.
And so this one.
So 1 line. So the arrow must be pointing at 60. Must be must be pointing at 66 miles per hour.
Correct. Next one.
So for C this time, it's basically a grams. It's basically a grams like thing. The arrow is pointing at it's pointing at roughly between 600 grams and 700 grams. So, and we know for a fact that halfway between 600 and 700 is 650. So, and in this case, it's 5 lines equals 10.
There isn't a difference at 10.
Wait, no, there's a difference of, there's a difference of 5.
From 600 to 700?
Wait, no, there's a difference of 100.
Mm-hmm.
And so 5 lines add up to 100. And the arrow is pointing, if 5 lines equals 100, then one line must equal 10.
So what do you have to do to go from 5 lines to just 1 line?
Wait, you need to divide it by 5.
Yeah.
So it's 20. So 1 line is 20.
Correct.
So the arrow is pointing at 620 grams.
So 600 is this big line here, and I think it's 2 away from that.
So it's 640 grams.
That's it. 640 grams. And last one.
Okay, so the last one is D, and it's basically a milliliters jug sort of thing.
Mm-hmm.
The only number that it's given us in D, however, is 1,000, which is the very top. But we know for a fact that half of 1,000 is 500.
Mm-hmm.
And so 500 would need to be placed between the very first line and 1,000.
Mm-hmm.
And so it's obviously above 500 milliliters. And so one line in this case must equal 100 milliliters.
Mm-hmm.
And so because the liquid that's in the jug sort of thing, since it's at the line before 1,000, it must be at 900 milliliters.
Well done. Any questions about anything there?
Nope, I don't have any.
So that was great. That was fine. Hang on, let me get rid of that. Okay, let's see. Let's save that. Let's see this one. Diagram shows the volumes which contains less. Okay. Let's try this one.
Okay, so the diagram shows the points measure jugs. Okay, so the main question is, which jug contains less juice? Jug A or jug B? And the next stage, explain how you know. Now, for jug A, it's smaller but wider, and jug B, it's smaller but thinner, and we know that already. But for jug A, it has less than 500 milliliters of orange juice, and in this case, one line must equal 100 milliliters.
Mm-hmm.
So jug A must have 400 milliliters of orange juice in it.
Mm-hmm.
And I already know that jug A has more than jug B, because jug B does not have more than 400 milliliters.
Yes. And so which jug contains less juice?
Jug B.
Yes. So this is less than 400. And so, reading scales.
I think maybe perhaps nailed it again.
Okay. And let me just skip back to, we don't need that. Oh, I got too far. Let's see. So what's the answer? Okay, how do we do this?
Okay. In this equation, n and m stand for positive integers less than 7. List all the possible numbers they could be. So n minus 1 equals m, and we know for a fact that they're both positive numbers less than 7. So for starters, n could be 6 and m could be 5.
Yeah.
We can also do 5 minus 1, which is 4.
Mm-hmm.
We can also do 4 minus 1, which is 3. 3 minus 1 is 2. And 2 minus 1 is 1.
Mm-hmm.
And we can't do 1 minus 1 because 0 is not a positive number.
That's it?
Yeah, that's it.
That's it. Well done. And it's good that you followed the system for it. This one.
A shop sells 4 flavours of smoothie: strawberry, kiwi, banana or mango. You can choose either milk or ice cream to make your smoothie. Draw a table of all the different combinations of smoothies you can choose. Now, for starters, we can choose milk with strawberry.
Mm-hmm.
Milk with kiwi, milk with banana, and milk with mangoes. And then we also have ice cream with strawberry.
Yeah.
Ice cream with kiwi. Ice cream with bananas. And ice cream with mangoes.
That's it. Well done.
Okay.
I think it'll be fine there. Okay, how about this?
Okay. Ben has 2 types of coin. The totals of each row and column are shown in pence. Find the value of each coin. Look for 2 of the same symbols in a row to start it off. So it says here that circle plus square equals 22p, circle plus circle equals 4p, and square plus square equals 40p. Now, looking at the second question, which is circle or circle, I think both the circle must equal 2p. This 2 plus 2 is 4.
Mm-hmm.
And the square must equal 20p. This 20 plus 20 is 40p.
That's it. Okay. This one.
The perimeter of a rectangular picture is 45 centimeters. It is twice as long as it is high. What is the length? What is the height h and length l of the picture? Think about how many times the height fits the perimeter. So it's twice as long as it is high, and the perimeter is 45 centimeters. So, and then it says, think about how many times the height fits into the perimeter. And so, for this, we would need to, so 45 centimeters. So, well, we know for a fact that when when added together, they equal 45 centimeters.
So there's two heights.
Two heights and two lengths. So we would need and when all of them are added together, they equal 45. So maybe. Not sure.
And it's twice longer than it is high.
Yeah, it's twice as long as it is high. So the length. So it's obviously longer than its height. And so the length must be I think that the length would height equals length equals 2 times height. Well, height 2 times length is 2 times.
So the length is 2 times the height.
Yeah.
And so this 2 times the height, what is that the same as?
It's the same as height times. Well, I was going to say height times 2, but.
So it's the same as this there, because they're equal.
Oh yeah.
And
so the length is the same.
So 2 lengths plus another length makes 45.
So 2 lengths plus another length is 45. So I'm thinking maybe that 10 times 2 is 20. No.
So basically 3 times the length is 45.
Okay, so So something times 3 is 45. So what time? Wait, 15 times 3 is 45.
Mm-hmm.
So it must be 15 centimeters long.
Yes. So the length is 15, and so the width.
So the width. The width must be the length is 15. The width is 50, not 15.
The length is twice the height.
The
The height, I should say.
So the length is twice as the height, and the height, it's awesome. Height must be 7.
Mm-hmm.
7 point. The height must be 7.5.
Yes. Very tricky one. Yes.
Yeah.
And let's say this one up the top. These true or false?
So look at the readings for each of these scales. Are they true or false? So the first one is a temperature thing. So -5. Actually, I think the arrow is pointing at -4.
Mm-hmm. So that's false.
Yeah. And the second one is it must be 490 grams. Wait. No. It must be. It must be 400 and 400. Well, I was going to say 475, but
Yep.
oh, it is true. Oh, okay.
And last one?
Last one is centimeters. 45 centimeters is approximately 1.5 feet. So 45 centimeters is like between the line not before 50, but the line after the line before 50. So that's 45. And it says it's approximately 1.5 feet, but it's more. But 1.5 feet is more than 45 centimeters, so that must be false.
Okay. Yeah. How was that for you, Richard?
I think I did pretty well.
Yeah, you did great. Yeah, so we'll continue this one next time.
So, okay, so.
And any questions for me in general?
No, I don't have any.
Okay. Well done, Richard. You did great. I look forward to chatting again next week.
Okay.
All right. Have a good week. Goodbye.
Bye.
Bye,
Bye.
Matt.
Bye. Thank you. Bye.
Okay.